Okay, this is the part 2 of the video, right? We'll continue from where we left off. We were discussing potential drop across various resistors, and we found out that the potential drop across these 2 points, right? This is, let us call this as point A, B, C, D, E, F, and G. This is the points we had taken, and we calculated VCT as 0.25 or 1 by 4 into 4, and this is 1 volt. And then we looked at VDE, right? And the current flowing into this is again 1 by 4 or 0.25. The resistance of this circuit is 1.2 volts, and this gives us 0.3 volts. Okay. Similarly, if I look at VGA, right? In this case, we have got the current flowing is 1.4, and the resistance of this is 2.8 ohms. So I'll get over here 0.7 volts. And if I add all these up, I get 2 volts. What does this mean? This means that the total energy available was 2 volt, right, to make the current flow in the circuit. Out of that, 1 volt got used up across 4 ohm resistor, 0.3 volts got used across this parallel circuit, and 0.7 volt got used up in the internal to overcome the internal resistance. This is how the energy was distributed across the entire circuit. Okay, so this is how we will calculate potential difference drop across a resistor in an electrical circuit. Right. Let's move to the second part, the current flowing in the parallel circuit. So for that, we will focus our attention on this particular DE part, right? I want to find the current flowing in the 3 ohm resistor and the 2 ohm resistor. So I'll call this I1, the current flowing into the 3 ohm resistor, and I'll call this I2, and let us call this R1 and R2, right? Okay. Now the current flowing into the 3 ohm resistor, which is I1, is given by V upon R, because current is V upon R, right? Now question is what we will take. We will take the V for the part DE, that is we'll take VDE, because we are trying to find out current flowing in the 3 ohm resistor in this part. So the potential drop we will take is across VDE, and R will be R1, the resistance of this the resistance across which we are trying to find the current flowing. So VDE we found to be 0.3 volts, and R1 is 3. So this will give me 0.1 ampere, right? That means current flowing through 3 ohm resistance is 0.1 ampere. Similarly, I2 will again be VDE, because 2 ohm is a part of the DE circuit, and resistance will be R2. This will be equal to 0.3, and R2 is 2 ohms. This will be 0.15 ampere. And if I add them up, I get 0.25 ampere. What does this mean? This means that 0.25 ampere current got distributed over here. 0.1 ampere passed through 3 ohm resistor, and 0.15 passed through 2 ohm resistor. This is how they got split up. Now, the thing that we should understand is that how the current gets split up depends upon the resistor, the magnitude of this resistor. Since 3 ohm is larger than 2 ohm, smaller current will flow through this, and 2 is the lesser one out of these two, so a larger current flows through this. Therefore 0.15 over here and 0.10 over here. That is how the current gets distributed, right? Okay, so this is how we have looked at the second part. Now also we have learned the method of finding out current flowing in the branch of a parallel circuit. One final point before I wind up this video is that when we discussed potential drop across the resistor, I said current starts flowing over here from A, it goes to B, then it passes through the emitter, comes to C, and we said part of the energy gets used up over here, right? And then part of energy gets used up across D and part over here. That is not entirely true. Actually what happens is that when the current is flowing through this AB, some part of the energy of 2 volts also gets used up over here through this wire up to here. Similarly, some part gets used up over here and some part also over here. But since the electric wire, the wire that is conducting this would be a good conductor of electricity, its resistance would be very, very less. For example, generally it would be made up of copper, and the resistance is very, very less. So the amount of energy that gets used up in the part over here would be extremely, extremely small. Hence we neglect that, and we consider only the energy which is used to overcome resistors like these 4 ohms, 3 and the parallel circuit over here and the resistor over here, right? That's the final point I wanted to make before I ended this video. I hope this two videos in two parts have given you a very good idea about how to find out potential drop across a circuit and current flowing in the branch of a parallel circuit. Right? Thank you.